Find the integral of sine 6x dx. To do that, you can apply the rule straightforward. What's the integral of sine? It's minus cosine, but we have 6x, so we write 6x, but don't forget we have to divide by 6, and we say plus constant, and that's it. Let's look at another example. What's the integral for secant 3x dx? Back to the rule, the integral for secant is ln absolute secant plus tangent, but how do we apply it here? We say it's equal to ln, we put absolute value, secant 3x plus tangent 3x, close the absolutes, and don't forget that we have 3x inside, so we divide by 3. And don't forget we have to put plus c always. What about the integral for tangent? Tangent, but here we have 4x dx. Integral for tangent is equal to minus ln, and we put cosine 4x, we close the absolutes, and we have to divide by 4, so it becomes minus 1 over 4. So either we put it over 4 here, plus constant, or we can write minus 1 over 4 ln absolute cosine 4x plus constant. So these are straightforward because we know the integral, or we need to memorize the integral for those types of trigonometric functions. What about if we have more complicated integrals, like if we have integral for cosine to the power 4x sine x dx? So here we need to apply the substitution method. So if we consider cosine x as u, so we say let u equal to cosine x. What about du? So du is going to be equal to minus sine x dx. So sine x dx is here, so we can replace it by minus du. So we have minus du is going to be equal to sine x dx. So we change the expression, it becomes integral for u to the power 4, and sine x dx is going to be to minus du, so we write du, and we keep the minus sign outside, and we do the integration now. What the integral for u to the power 4 du is going to be equal u to the power 5 over 5, and here we have minus plus constant, and then we replace u by cosine x to return it to the original situation. It becomes equal to minus u to the power 5, which is cosine x to the power 5 over 5 plus constant. Let's do another one. Here we have integral for cosine to the power 4x sine to the power 3x dx. If we consider u as the cosine, so we say let u equal to cosine x, then du is going to be equal to minus sine x dx. The du is minus sine x dx, so we have sine x dx here, but here we have sine cube. So what do? We can break it down. To break it, we say integral for cosine to the power 4x. Break down the sine to the power 3, it becomes sine squared x times sine x dx. And don't forget, here we have minus du is going to be equal to sine x dx. Also here we have sine squared. You know that sine squared x is equal to 1 minus cosine squared x. So we can replace it. So it becomes integral cosine to the power 4x bracket 1 minus cosine squared x, and here we have sine x dx. Now let's replace all by the u, so it becomes integral. So it's going to be equal to cosine to the power 4x, which is u to the power 4 bracket 1 minus u squared, and sine x dx is going to be equal to minus du, so we put du and we put minus outside. Now simplify, it's going to be equal to minus integral u to the power 4 times 1 u to the power 4, u to the power 4 times minus u squared, it becomes minus u to the power 6 du. Integrated, it becomes minus u to the power 5 over 5, and remember, minus we multiplied by here, it becomes plus u to the power 7 over 7 plus constant, and finally replace u by cosine x. Is going to be equal to minus cosine x to the power 5 over 5 plus cosine x to the power 7 over 7 plus constant, and that's it. What about if we have integral for sine squared x dx? What do we do here? There is a relation between the sine squared and the cosine 2x. If you check it, you know that cosine 2x is equal to 1 minus 2 sine squared x. So if we take 2 sine squared x to the other side, to the left side, it becomes 2 sine squared x is going to be equal to 1 minus cosine 2x. Just switching. Move this here, it becomes plus because it is minus, and move this here, it becomes minus cosine 2x. And now divide by 2 all of the equation. It becomes sine squared x is going to be equal 1 over 2 minus 1 over 2 cosine 2x, and then we can replace it. So replace sine squared x, it becomes integral of 1 over 2 minus 1 over 2 cosine 2x dx. So what's the integral for 1 over 2? It's going to be equal 1 over 2x. And what's the integral for 1 over 2 cosine 2x? Is going to be equal. Integration for cosine is sine. So it becomes, we have minus. Let's put 1 over 2. Now sine 2x divided by 2. So we have 2 and 2, so we multiply them together, plus constant. So the final answer is going to be equal to 1 over 2x minus 1 over 4 sine 2x plus constant. What about the integral for cosine squared x dx? Similarly, we have a trigonometric identity between cosine 2x and cosine squared. We have cosine 2x is going to be equal to 2 cosine squared x minus 1. Similar to the previous one, but cosine squared at the beginning. So if we find cosine squared in terms of cosine 2x, then we can replace it. So we can say cosine 2x plus 1 is going to be equal to 2 cosine squared x. Divide by 2, divide by 2, divide by 2. You will get cosine squared x is equal to cosine 2x over 2 plus 1 over 2, or you can write 1 over 2 cosine 2x plus 1 over 2. So we can say the integral of cosine squared x dx is going to be equal, integral for cosine squared x dx is going to be equal, replace cosine squared, it becomes integral for 1 over 2 cosine 2x plus 1 over 2 all dx, and we find the integration. So now, what is the integral of 1 over 2 cosine 2x? Integral for cosine 2x is sine 2x over 2, and we have 1 over 2 outside, it becomes 1 over 4, plus integral for 1 over 2 is 1 over 2x plus constant, and that's it. Bye for now.